Hi, welcome you all on Physics Addhyan. So today, as the topic suggests, that problems on projectile motion and circular motion, that is indeed the topics that we learned in previous lectures. So I will start with a very simple question on projectile motion, then I will move forward. So your first question is that there is a particle of or body, let's say of mass m at some height h, and a particle is thrown with an initial velocity u with some certain angle theta from the horizontal, then you have to find out what is the total time of flight from here to here, and what is the distance or the range, what we called as r. So you have some parameters, that is u, theta, h, and you have to find time of flight and the range of it. The parameters that are given, that your initial velocity is given to be 10 meter per second, your height from origin is given to be let's take to be it as 100 meter for our simplicity, and let's take theta your let's say 45 degree. Okay, so that is the question, that and theta is from horizontal, so I should mark it here from horizontal. Okay, so this is the question now. And this is under gravity. Obviously it is obvious that it should be under gravity. So my g is in this direction, so let us write the equation of motion. My ax will be 0 because there is no acceleration in x direction. Ay is equal to our minus g. Your ux will be your u cos theta in this equation, because at this point it is u and this is theta, so this is your x-axis, this is your y-axis. So u is your 10 meter per second, cos 45 degree is 1 by under root 2. Okay, let's take one more simplicity for make this problem very simple. Not I'm not trying to make it mathematically difficult. So let's take the initial velocity to be root 10 root 2 meter per second. So your ux will be multiplied by root 2, so that is 10 meter per second. And if you take your ui, this problem is just to have a clear idea to use the equations of motion, so that's why I'm making it too simple. So it is sine 45 degree, and this will be 10 root 2 into sine 45 is 1 by root 2, and this is also 10 meter per second. Now if you go and write the x equation of motion, so your x equation of motion will be Sx is equal to ux into t plus half of ax into t square. So your Sx, that is similar as range, is equal to ux is 10 meter per second into time and plus 0. So your range is equal to 10 into t. So whatever value of the time will be, or the total time from this point, let's call it as a to b, the time of flight. So it will be your t here that you have to use. So let's write the y equation of motion. So your sy will be uy into t plus half of ay into t square. So at initial point u was at height h comma 0, and at final point you will be at this point a, you will be at h comma 0, and at point b your h will be y directional will be 0 and x direction will remains as r. So in y direction you have changed from h to 0. So your sy is, if you take this as your origin, this as your origin of this projectile motion, so okay, that is only for your directional convenience. So if you take your point of projection to be your origin, then this will be your x-axis, this will be your y-axis, and same thing. Okay, let me think it. Okay, that is right. So your sy will be minus of 10 meter, because h is, sorry, not 10, it is 100 meter. So it is minus 100 meter from this origin O. Ui from the same origin, ui will be your 10 meter per second into time t plus half of minus g into t square. And if you substitute your g to be 10, then your 10, 10, 10 will cancel. So this will be minus 10 is equal to t minus t square by 2. This is a quadratic equation. If you solve it, so this equation will become t square minus 2t minus 20 is equal to 0. When you solve this equation, you will get under root v square minus 4c. You will get approximately 84, 11 by 2 or something near approx 5.5 seconds. This is a rough estimate. Please check the calculation. And for range, so your range will be 10 into 5.5. It is approximately 55 meter from this origin. So this is your 55 meter from here to here, 55 meter. So that is similar to this. So in this type of problem, you can take your point of observation, or from the point where you have thrown the projectile as your origin. So that will be a simpler problem, or you can choose your origin anywhere in the system. Only the thing that will be difficult is your mathematics. So to make our mathematics simpler, we can shift our origin as our convenience. So that was the first problem based on the projectile motion. Now we will move something that is related to circular motion and projectile motion. So your next problem is that there is some origin O, and at angle some theta there is a projectile with initial velocity u, and it goes some curve like this, and this is your x-axis, and let's say this is your y-axis. Now the question is, there will be some maximum point here, and at that point you have to find the radius of curvature of this circle at the highest point. So you have to find this r. Okay, if you take a small element here, that part of your parabolic path make a circle, and then you will get that r, that is defined as the radius of curvature. So in this figure shown, find radius of curvature at highest point. Okay, so that's the problem. So from our knowledge of radius of curvature that I have defined in circular motion, your radius of curvature turns out to be 1 plus dy by dx of whole square power 3 by 2 divided by d square y by dx square. You know y in terms of x, and you substitute in this point for highest point, you will get the radius of curvature. But we are not going to do this problem with circular motion. So because there are two type of motion, projectile motion and not circular motion. Its motion is projectile, but we are relating something with circular motion. So how will we proceed in this problem? It is clear that your let's write what we know, that x-axis velocity is your u cos theta, and your y-axis velocity will be similarly u sin theta, and the acceleration, your ax will be 0 and your ay will be minus g. So see, your acceleration is 0 and your initial velocity is u cos theta. So in x direction, your velocity is constant because there is no acceleration. So your vx will be some constant, and that is equal to your initial velocity. That is always true for this type of projectile motion because your ax is 0. So now use this concept that vx is equal to constant here. So at any given instant of time, at this particular time when it at highest point, your velocity will be u cos theta. So in this type of, if it is a circular, treat it like this is a circular motion of radius r, and your highest point velocity is u cos theta. Now apply the circular motion concept. For circular motion concept, I told you write the radial equation of motion, that is MAR. So your FR, radial force, is nothing but the central force, the force towards the center, that is mg. Towards the center I am taking with direction, so it is mg is equal to m, and radial acceleration is v square by r. V square by r. So here your v is equal to u square. V is equal to u cos theta. So it is u cos theta whole square. So your m will cancel out, and your r turns out to be u square cos square theta upon g. So that is the radius of curvature of this projectile at the highest point. So that was the problem. It was a very simple problem because I have told you to find the radius of curvature at the highest point. So what will be the radius of curvature at any point in this motion? At any given instant of point, let's say if you are a certain point of x in this, you have a certain point of y. So what will be the radius of curvature of this? What will be the radius of curvature of that point? So it depends upon this angle, because at this height, let me change the color. At this height, the horizontal angle, the velocity which makes the angle with the x-axis is 0 at this highest point. So if the particle is at this point, so it will make some angle, let's say alpha, with the horizontal. Now we are trying to relate this alpha with the velocity, and then we will proceed the next question. So our next question is going to be this, that if there is some time of, let's say, xy axis, this is your x-axis, this is your y-axis, and similar question, there is a projectile of mass m with some initial velocity u with some angle theta, and it is thrown at some angle and it traces some path like this. And now we are going to find a general term. So suppose at any given instant of time, the particle is at here and its velocity will be in this particular direction, it is v, and it makes angle alpha with the horizontal. Now we are going to find out the radius of curvature of this circle, which is at which center is this, and this is the r. Now we are going to find out this r, which makes an angle alpha with this projectile. So I have just rescaled this circle r at here. So this is your center, and at this point of contact, your velocity is v in this direction. That makes an angle alpha with the horizontal. This is angle alpha. And in this question, if the particle is here, let's write its mass m, so its force mg will be acting downward direction. So this is your mg. Okay, so if I draw a tangent from m to the center o, so I'm drawing the tangent like this. So this line mg and this horizontal line makes an angle 90 degree. This o, this radius, and this velocity will also make an angle 90 degree. So this angle will be your alpha. So again, write the ux equation of motion. Ux will be your u of cos theta. Your uy will be u of sin theta. Your ax will be again 0. Your ay will be minus g. Since ax is 0, so we can again imply that your vx is equal to constant. Your x acceleration velocity at any given instant of time is constant. So this velocity v will be something that we don't know, but we know at this given instant of time, its x-axis velocity is your u cos theta, that is nothing but vx. Okay, if this is vx, then we know what will be the value of v. So we can write here as v cosine alpha. This velocity's cos component will be equal to vx, that is equal to u cos theta. So your velocity will be u cos theta divided by cos alpha. So that is your velocity at that angle alpha from the horizontal. So now write the equation of motion. Fr is equal to mar. Your force in the radial direction, force in this direction. So force in this direction is mg cos alpha. So this is mg cos alpha. This is mass m. Your acceleration is v square by r, and your this v is this v, the velocity at that point. So this is m u square cos square theta divided by cos square alpha. This is mg cos alpha. M will cancel. This implies that your r, sorry, I missed one r here. Yeah. So r is equal to u square cos square theta divided by g cos cube alpha. So that is the radius of curvature at any given instant of time that may when the velocity makes an angle alpha with the horizontal. So let's match this result with your previous result. Put alpha is equal to 0 at maximum height. At maximum height this will be the case. So your r is equal to u square cos square theta by g. That is nothing but the problem that we just did, this r square cos square theta by g. So that was the most general approach to follow. So now let's move on our third problem, and this is going to be a mixture of projectile and circular motion. So let me frame the question first. So suppose I have a pendulum which is suspended from some point O. So let's say that that is point O, and I have a pendulum suspending from here. So let's call, let me draw it again. Okay, so this is your pendulum having some bob of mass m, and that is your point of suspension, and this I represent by some O. Let's get an erasure. Okay, so the point of suspension of this bob is O, and it has some length L. And if the bob is given to be some velocity, let's say the velocity is your initial velocity of this bob is given to be under root of let's say 4gl, then my question is following. So the question is, to what height above point of suspension the bob will rise? The bob will rise. So your point of suspension is this O. So let's frame this as level O. So this is your reference point. I am asking what will be the maximum height that from the point of reference that bob will move. So I have to find this h. If the bob will move this height, then what is this h? That is a simple question that I am asking. So since the velocity is less than, so if this velocity was something, I don't remember is that exactly, but I think it was under root of 5gl. If that minimum velocity is given to your pendulum or some circulating object at the lowest point, then it will complete a circle. So the first thing that we can conclude is that it will not complete a circle, not complete a circle. So if the velocity was more than 5 gl or less than or is equal to 5gl, then it will complete the circle. Then your maximum upward, the height of from the suspension will be this length L. So we know that h is going to be less than L. The first conclusion that your answer should be less than L, because your u is less than under root of 4gl, because your initial velocity is less than under root 5gl. So it will not complete a circle. That's why your maximum height should be less than the length of this pendulum, that is L. The first thing. Now the second thing that you see in the motion, that let's say that it will go some point here. The pendulum will go with some height. Let's call this height as, okay, let me connect it first, that let's in the motion at any given instant of time, the bob will reach a maximum distance like this. So your bob will reach some distance r from this horizontal. So let me make some other consideration, because let the angle at which the bob will stop will be your theta from the vertical, and this is your r distance. So if I connect this like this, so at the maximum height, or not the maximum height, I will say, when the circle is for this velocity under root 4 gl, the bob will go some certain height, that is l plus r. I am calling this above distance as r here. So, and it makes an angle theta with the vertical. This string makes angle theta with the vertical when the circular motion is at extreme position. So at this extreme position, your tension will be zero. The first thing, your tension will be zero in this string at this extreme condition, at the extreme position. So let's write the radial equation of motion at this point. Your mg will be acting downward direction, mg. It will have some instantaneous velocity in this direction, v, because of the circular motion, because the instantaneous tension is zero, not the velocity. Okay, so your mg will be in this direction, and this will also make an angle theta. So your radial equation fr is equal to mar. Fr will be your mg cos theta, because that is your center of the circle. So this distance, or the force component in this direction is fr. So fr will be mg cos theta times m, and your acceleration, radial distance acceleration, is v square by r. So you can get the magnitude or the velocity square, that is nothing but g, and your r is equal to l here. So you will get gl cos theta. That is the first thing, that you at the extreme point you will find the velocity to be gl of cos theta. Now when we have did some problems in circular motion also, there we have seen that I can find this velocity v in this terms of u by using this height. So this height is your r and this height is your h. So I can write the equation of motion, that v square, the final velocity at point A, is equal to u square minus of 2gs, because the velocity will decrease, and we have discussed how this u square is equal to u square minus 2gs came in circular motion concept. So your velocity at point A, v square, is equal to under root 4gl. So this will be 4gl minus 2g, and let me call this as h prime, and h prime is a distance, h prime is a distance from this u to this v. So your h prime is equal to h plus r. So this is h plus r. And if you see what is your r, this is your l and this is your r. So your r will be l cos theta, because this is your l, this is your theta, and this is your r. So r is equal to l cos theta. So you can write v square is equal to 4gl minus 2g. Your h is l plus r is l cos theta. So if you solve this equation, and you know this v is equal to gl cos theta, so put it here. Gl cos theta is equal to 4gl minus 2gl minus 2gl of cos theta. So this will become 3gl of cos theta. So 3gl cos theta is equal to 4gl, 2gl, not 4gl, because 4 and 2 will cancel. So this will equal to 2gl, gl will cancel. This implies that your cos theta will be equal to 2 by 3. So when cos theta is equal to 2 by 3, at that given instant of time, your tension will be 0 at, okay. So we have concluded three things. The first thing is that our maximum height will be less than L. The second thing is that our velocity will be GL of cos theta. And third term, we have concluded that cos theta is equal to 2 by 3. So my velocity square, V square, will be 2 by 3 of GL. Now, will this particle will stop here? No. So what happens next? The second question. So my R from this 0 to this, I have calculated that R is equal to L cos theta, and your cos theta is 2 by 3. So my R will be 2L by 3, that is 2L by 3. So is this the maximum height? No, it is not the maximum height, because this bob has an velocity v at this point A, and it makes an angle theta with the horizontal. Now it will be a projectile at this point. Okay, so we will have an additional height, that is, let me call this as h double prime, because I have used prime symbol. So this is h double prime, and what that h double prime is, the maximum height of that projectile, and you know the formula of the maximum height of the projectile. So use this quantity u and theta and all that thing, and we will give some result, and let's see what that comes out to be. So we know these parameters, h is equal to less than L and all that things. So my maximum range of this projectile will be u square sine square theta upon 2g. My u square is here v square, because the initial velocity will now be b, divided by 2g, and your sine square theta you can calculate by under root 1 minus cos square theta. This is under root 1 minus 4 by 9. So 9 minus 4 is 5. Sorry, this is sine theta, not sine square theta. So you will get under root of, where is the ratio? Yeah. So you will get under root of 5 by 9. So this is 5 by 9. So you will, this is sine theta, this is sine square theta. So this is 5 by 9. So you will get 5 by 9 here. Now you can substitute this. Now you can substitute this u square to here. You will get h double prime is equal to 2 by 3 gl into 5 by 9 into 1 by 2g. This g will cancel, 2 will cancel. So this is 5 by 27 of L, h double prime. So your maximum height, that will be your r distance. So from this reference we have some distance angle theta from here. So this distance was r, and now the projectile maximum height will be your h double prime. So your maximum height, h maximum, will be r plus h double prime. So what your r is? R is your L cos theta. Your L cos theta is 2 by 3. This is 5 by 27 L. So 9 to the 18, 19, 20. This is 23 L by 27. This is h maximum height from this point of suspension. And you can see that 23 by 7 is less than 1. So your h maximum is less than L, what we expect from our inspection at the initial time before solving the problem. So indeed this result should be correct, because it's match our intuition. So that was the problem, that is mixed with some projectile motion and some circular motion concept. If I'm not wrong, then 1 or 2 problem is given in H.C. Verma book on this concept, where the question is something similar. I don't exactly remember the question, but you can see it, that what will be the minimum velocity u that this particle u will hit the this part, this your point of suspension. So you have to find the minimum velocity u such that the particle goes up after the projectile motion, it will hit your point of suspension. So you can do that problem as an exercise, or you can find in your H.C. Verma book. I don't remember exactly what that question number is, or but you will find that in circular motion or work energy chapter theorem. So that was all about the projectile motion and circular motion concepts. So now I think we are done with circular motion problems, and we have completed the theory part and some we did some of the numerical parts. Now you can practice the Kleppner book at your own, and I think that you will be able to do all the problems. So in the next upcoming lecture, we will be dealing our conservation laws, work energy theorem, linear momentum conservation, energy conservation, and some concepts of angular momentum. So whatever the problems that we have did in using the Newton's laws of motion can be done by energy conservation or law conservation of laws. So we will see some problems there also. Thank you. And if you have not subscribed the channel, do subscribe the channel for latest updates, and your comments are always welcome. Thank you.